from illness using your own stem cells? Although it seems like science fiction, modern medicine has made significant advances lately to practically turn science fiction into reality. Needless to say, stem cells are one of the most significant discoveries. Stem cells are undifferentiated cells that are present in all stages of life that have the ability to evolve into differentiated cells that are the essential components of tissue and organs. Moreover, stem cells are the ones that replace the worn-out cells when they die. For instance, every couple of weeks, the skin cells are replaced, and liver cells are regenerated every 300 to 500 days. Therefore, the ability of stem cells to replicate itself and to differentiate into several types of cells enable researchers to develop medicine that is more customized to replace parts of damaged or infected organs.
Now, I want to talk to you about something really fascinating. Embryonic stem cell, or ESC for short. Do you guys know about ESC? These are super spacious cells that come from the inner cell mass of a blastocyte, which is basically an early stage embryo. Do you know that the coolest thing about ESC is that they have the power to turn into any type of cell in our body? And not only that, they can keep renewing themselves and multiplying like crazy. This made them a hot topic in research because they could be used to treat all sorts of diseases and injuries. But hold on, there's a catch. Some people have concerns about using ESC because it involves destroying human embryos. So it's a bit of a controversial topic. Nonetheless, ESC research has given us some amazing insights into stem cell biology, disease modeling, and regenerative medicine. It's a field that's full of potential and promise to make some big waves in the future.
Adult stem cells, or ASC, also called somatic stem cells. They are the undifferentiated cells which reside in specific differentiated tissue in our body. ASC are rare and they play a role in repairing and maintaining the resistant tissue each day. Unlike ESC, their ability to generate various types of cells is restricted because ASC only can generate the cell types of tissue where they live. For example, ASC in bone marrow only create new blood cells. However, some other evidence suggests that ASC also have the ability to generate other cell types. ASC are widely used in clinical application compared to ESC, not only because they do not carry ethical baggage, but also because their practical advantages have given rise to many current clinical trials. Next, I pass to Evan.
Whenever we talk about something, there will always be pros and cons, right? So, what are the advantages of using this stem cell therapy? Firstly, it is commonly known that patients will need to wait for a long period of time to obtain an organ that suits them and would not be rejected by the body, as the blood type is not accepted. Or some other factors might also lead to rejection of the organ transplant. But by using stem cells, as the cell is from our own body, it will not be rejected and would also regenerate cells in the body instead of losing the cell when we have the injury. Secondly, the treatment is very versatile, as it could be used at multiple places in your body. It could be used to treat joint injuries, it could be used to treat your ligament injuries, nerve injuries, and many more. Most importantly, patients do not have to suffer from a prolonged recovery state like in typical surgeries that involve sewing the cut area. Stem cell therapy can simply be carried out by injecting the stem cells into the injured areas, and the patient could feel free to leave the hospital. Stem cells would regenerate and heal the injury of their own.
Stem cell therapy has the potential to cure a wide range of disease and injuries, but it also carries some risk. Adult stem cell differentiation limitations are uncertain. It cannot be grown in culture for lengthy period of time, and it is difficult to locate and purify. There is no mechanism for producing large quantities of stem cell in culture, and the procedure of producing ESC lines in embryonic stem cells is inefficient. When used directly from the ESC undifferentiated culture, prepped for tissue transplantation, they can cause tumors or cancer growth. Methods for assuring the reproducibility and maintenance of differentiated tissues in induced pluripotent stem cells are unclear. Viruses are currently used to transfer embryonic genes and have been shown to cause cancer.
Stem cell therapy has revolutionized in the fields of medicine, offering new hope for various conditions. But what does the future hold for this groundbreaking treatment? One exciting future application is in heart disease. Stem cell therapy could lead to innovative treatments for conditions like ischemic heart disease. By using special stem cells, scientists aim to repair and rejuvenate the heart, potentially transforming the life of millions. Another area where stem cells show promise is spinal cord injuries. By activating dormant cells around the injury, stem cell therapy may trigger regeneration, helping patients regain lost function and mobility. It's a remarkable step forward in the quest to overcome these devastating injuries.
Other than creating new tissues to heal our body, stem cells can also be used to help understand how the body works, especially the mechanism that the body uses to create new tissues in a controlled and regulated way. The ultimate objective of stem cell research is to achieve significant medical advancements, as it offers hope to people suffering from cancer, diabetes, cardiovascular disease, and many other disorders. Now that we are aware of the true potential of stem cells, we can develop personalized and effective treatments for a variety of diseases using our own cells. This brings the promise of regenerative medicine a step closer to reality.